Planet Earth. Chapter 1. Solar Storms. Page 135.
Solar storms. In 1859, an amateur astronomer named Richard Carrington climbed the stairs to his private observatory near London. He adjusted his telescope and projected an image of the sun onto a screen. He was looking at sunspots, areas of the sun that appear darker because they are slightly cooler than the surrounding areas. Suddenly, two patches of white light appeared around one sunspot. Before dawn the next day, spectacular displays of red, green, and purple light, known as auroras, lit up the skies as far south as Panama in Central America. In the eastern United States, people were able to read newspapers outside in the middle of the night. Further west in the Rocky Mountains, the light confused campers enough to get up and start cooking breakfast. Some people even thought their cities had caught fire. What Carrington had observed was a solar superstorm. A massive eruption on the surface of the sun sent billions of tons of electrical and magnetic matter hurtling through space. It even caused damage here on Earth. When the matter collided with our planet's magnetic field, it caused electrical currents to surge through telegraph lines, disrupting communication. No solar superstorm as powerful as the 1859 event has occurred since. That's why scientists find it difficult to calculate the impact a similar storm might have on today's more wired world. A hint came in 1989, when a solar storm a third less powerful than the Carrington event caused 6 million people in Canada to lose power. A Carrington-class storm could leave millions without light, drinking water, sewage treatment, heating, air conditioning, fuel, and telephone service for months. Few objects seem as familiar as the sun. There it is, up in the sky every sunny day. Yet few objects are so strange. Look through a solar telescope, and the sun is transformed. Streams of light the size of planets rise into black space, only to come back down hours or days later, as if controlled by some unseen force. Neither solid, liquid, or gas, the sun is made up of plasma, the fourth state of matter. Scientists are learning more about the sun and how solar storms form. The sun is packed with magnetic fields, some emerging on the surface as sunspots. They help to power the solar wind, sending a constant stream of particles out into the solar system. These fields can also become entangled with plasma, forming gigantic loops that are illuminated by the hot, glowing plasma. When loops cross, they cause the enormous plasma eruptions known as solar flares. Such flares release intense energy into space. The Carrington event consisted of a powerful solar flare that produced the second of a rare pair of plasma eruptions. The combined force of both eruptions squashed the area where the Earth's magnetic field interacts with the solar wind, down from its normal altitude of 65,000 kilometers to 6,500 kilometers. The matter entering the upper atmosphere set off intense auroras over much of the Earth. A Carrington-class superstorm probably occurs only once every several centuries. But even much smaller storms can cause considerable damage, especially as humans become increasingly dependent on technology deployed in space. Solar storms disrupt the ionosphere. This is the layer of Earth's atmosphere where auroras occur, 100 kilometers above the Earth's surface. The pilots of the nearly 11,000 flights flying over the Arctic each year rely on shortwave radio signals bouncing off the ionosphere to communicate in an area beyond the range of communication satellites orbiting over the equator. When space weather disrupts shortwave communications, planes flying these polar routes have to be diverted. This can cost as much as $100,000 a flight. GPS signals are also affected, resulting in positioning errors. This means that surveyors must pack up and go home. Floating oil drilling rigs have trouble remaining on station, and pilots cannot rely on GPS-based systems employed for landing at many airfields. Unlike satellites in space, most power grids have no built-in protection against a powerful solar storm. Since large transformers are grounded to the Earth, magnetic solar storms can produce currents that could cause them to overheat, catch fire, or explode. The damage could be catastrophic. A solar storm as strong as the 1859 event could damage the entire grid. Such a storm might send hundreds of millions of people back to a pre-electric way of life for weeks or months. In 1859, the world had few tools for studying the sun. Today, scientists are able to use satellites to constantly monitor our home star. One pair takes 3D images revealing how plasma eruptions speed out through space. Another monitors the solar winds. Scientists cannot be sure of a storm's intensity until it reaches this satellite, sometimes a mere 20 minutes before it reaches Earth. Many researchers are therefore concentrating their efforts on forecasting a storm's potential strength and its likely arrival time, allowing vulnerable systems here on Earth time to prepare.